Hello and welcome back to another episode of Math with Zone. Today, we are going to be solving absolute value inequalities, which is sometimes way more tedious than solving an absolute value equation. So let's get into it. All right, so let's say we have an absolute value of x, and it's just a simple absolute value of x, and we're going to say it's greater than or equal to 3. Okay? So if we are solving that, just like an equal sign, we're going to have to be like, well, x would be greater than or equal to 3, one positive and one negative, just like it was an equal sign. But when you do the negative version, you have to flip the inequality sign. So it was greater than, now it's less than, and negative 3. Okay? So let's graph it. But more importantly, we will have to be aware that checking our answers for this is going to be annoying. All right? So graphing it typically means that we're putting it on a number line, and the number line serves two purposes. First purpose is it allows us to visually see the answer. But second purpose is it will help us when we find our answers, because sometimes the graph and our answers lie. All right, so negative 3 I plotted, and it is filled in a solid circle. It's supposed to be on the line, but I like it when it's above it. And as long as the x is on the left side, it goes the direction that it points. So it's going to the left. And at positive 3, filled in because it's equal to, it goes to the right. We have to check our answers, though, and you can't just check your answer by plugging in 3 and negative 3. You have to check it within the zones, and there's always going to be 3 zones. There's the less than negative 3 zone, so I'm going to plug in any number smaller than negative 3. Any ideas? I'm going to plug in, let's go, negative 5. It doesn't matter. Pick an easy number. Any number between negative 3 and 3, which you could plug in 0. You could plug in 1 or 2. I'm going to plug in the number 1. Why not? And then any number bigger than 3, which is, we'll go with positive 5. And that part's going to go really quick, hopefully. If you plug in negative 5, is the absolute value of negative 5 greater than or equal to 3? Well, that's going to be 5, and 5 is bigger than 3, so yes, that zone worked. We expected it. It's a part of our answer. See how I graphed it, and it's a part of our answer? So we expected that. Now, 1 is not a part of our answer, so we should check that, and we should expect it not to work. But sometimes it will. You have to be careful. Is the absolute value of 1 greater than or equal to 3? Well, no. 1 is not greater than or equal to 3, so this did not work, and we expected that as well. And then 5. If we plug in 5, the absolute value of 5 is, of course, bigger than 3, so the 5 worked. And that means that our answers that we originally had are correct. Some of the time you will be canceling out answers. So you'd be like, okay, that didn't work, and it's gone. It poofs out of existence. Some of the time, the middle section might work when it shouldn't have worked. You have to just be very careful, okay? So let's get another one like that. Let's say that we have, let's say x plus 2, absolute value of that is, ooh, this is sideways. Here we go. Is less than or equal to negative 2. All right? So we solved that, and we got x plus 2 less than or equal to negative 2. X plus 2 greater than or equal to positive 2. You switch the sign and switch the inequality, and now you solve both. So x subtract 2 would be less than or equal to negative 4, because negative 2 minus 2 make negative 4. And subtract 2, we get x is greater than or equal to 0. So those are our official answers as of right now, but we don't know if they're going to stay that way. So here we go. We got negative 4, and it's also filled in because it was also equal to this away. And we have 0. And it's going to the right because it's bigger than those values, and it is going and pointing to the right. And then we have to test out some numbers. So I'm going to plug in negative 5, again, because it's smaller than negative 4. I'm going to plug in a number in between negative 4 and 0, which is like, I don't know, negative 2. Oh, no, negative 2 seems that's too many 2s. So I'm going to plug in negative 1. And then I'm going to plug in a number bigger than 0. Any number bigger than 0, let's keep it exciting and go with 10. 10's a nice even number. So plugging in the negative 5. Negative 5 plus 2 is the absolute value of that less than or equal to negative 2? Well, this is negative 3, and the absolute value of negative 3 is positive 3. Is positive 3 less than or equal to negative 2? No, it's not. So that means this is wrong, and this negative 5 zone, this entire zone, is going to poof out of existence. It's not a solution. This is wrong. Like, it's wrong. That's okay. Things can be wrong. It's called extraneous. Plug in the negative 1. We're not expecting this to work, but who knows? The other one didn't work, and it was supposed to work. So negative 1 plus 2 less than or equal to negative 2. That would give me negative 1 plus 2 is 1. Is the absolute value of 1 less than or equal to negative 2? Also no. So that didn't work, but we didn't expect that to work. So 10's our only hope. Maybe 10 will work, maybe it won't. If we plug in 10 plus 2, this is not looking good. 10 plus 2 is 12, and 12 is for sure not less than or equal to negative 2. So this also didn't work. And if you watched my first absolute value video, you realize that you should always be on the lookout for when an absolute value is equal to a negative number. Can an absolute value equal a negative number? Absolutely not. Can it be less than a negative number? Even worse, it can't even be negative, let alone less than a negative number. So that's why this is, quite simply, because it equaled negative 2, no solution. But with inequalities, you need to be even more careful. Because let's say it was the opposite of this. Let's say instead of it saying less than or equal to negative 2, if it said greater than or equal to negative 2. And in fact, if it said that, it would completely switch and go from no solution to infinite solutions in a heartbeat. Because will an absolute value always be at least positive? Yes. Which means that it will always be greater than any negative number, and all three of these would have worked, and you would have had an infinite solution scenario. So you need to be very careful with this. All right? Let's try another one. Let's try something that's a little more sophisticated. Let's try the absolute value of x is greater than x minus 1. Sophisticated indeed. This one's probably going to be the last one we do. So x, because the absolute value bars are isolated, greater than x minus 1, and x less than the quantity of this side, x minus 1. So you have to distribute the negative and make sure you make both things negative, which is going to be less than negative x plus 1. Now, because there are x's on both sides of this inequality absolute value equation, you should expect some weird things to happen with our solutions. All right? So I would expect some things to be like normal and some things to not be normal. And in this case, it's going to be really weird because the x's cancel out. And we get 0 is greater than negative 1, which is always true, which would imply that this automatically is going to be infinite solutions because 0 is always greater than negative 1. What about over here? Well, we have x less than negative x plus 1. If we add x to both sides, we get 2x less than 1, which means x is less than 1/2 when we divide by 2. So over here we got infinite solutions, but over here we just have less than 1/2. So this might be infinite. It might just be x is less than 1/2. Let's find out. Okay? Let's plot the 1/2 because that's the only real number we have. And it is a hollow circle because it's not equal to, and it's smaller. All right? So we need to plug in some test numbers. What is a number smaller than 1/2? Well, that would be, 0 is smaller than 1/2. And a number bigger than 1/2, I'm going to go with 5 because I like the number 5 today. All right? So if it works on both sides, we get infinite. If it works on just this side, we have less than 1/2. And that's the only options we get. So let's plug in 0. 0, absolute value of that, greater than 0 minus 1. Make 0 greater than negative 1. Is 0 greater than -1? Well, we already proved up there that it is. So this part worked. What about 5? 5 greater than 5 minus 1 would be 5 greater than 4, which also worked. All right. So this also is now included in our answer. And we're kind of looking at an infinite solution. The only question now is, that's a hollow circle. Does 1/2 work? Because maybe, just maybe, 1/2 is the only part of this entire infinite solution that doesn't work. So I'm going to plug in 1/2, which is normally something I do not do. I normally don't plug in the actual only answer I get. If we plug in 1/2, the absolute value of 1/2, is that greater than 1/2 minus 1? And we get 1/2 greater than -1/2. Is 1/2 greater than -1/2? Yes. So that means even the 1/2 is included, and I kind of wasted about 20 seconds of our time because this is, in fact, infinite solutions. Now, do not think that it's only going to be no solution, an infinite solution, or what you actually had. Sometimes, whenever you're doing your problems, like we had here, sometimes it'll work on the left, it won't work on the right, and maybe works in the middle. You really just can't tell. You have to plug in your answers and take out the things that are there, and then whatever you have left over that's still remaining as an answer is what you get, okay? So, that's going to do it for this episode. Until next time, I will see everybody later. Bye.